Hey guys, good evening and welcome back. Welcome back again to your Unacademy NEET English channel. I believe all of you are doing great, having a good time. So people, quickly, let me know in the chats if all of you can hear me, if I'm perfectly audible and visible to every one of you. Quickly, let me know in the chats with some fire emojis. Everyone in the chats. Everyone in the chats, yeah? Am I perfectly audible, visible to everyone? Quickly, people, I would want you guys to light up the chat box with some fire emojis. Good evening, guys. Good evening. Good evening. So let me know quickly. Let me know quickly in the chats, yeah? I want the chat box to light up with the fire emojis. I want the chat box to light up with the fire emojis. It should light up with the fire emojis. Yes, you heard me right. Yes, you heard me right. Perfect, people. Perfect, perfect. So as you all must be knowing, this is going to be the first session of the Phoenix Pro batch, right? When it comes to the subject chemistry. And my dear students, this particular session, it won't be repeated again. Okay? So I would want you guys to watch this particular session till the end. And in this particular session, we shall be starting with the chapter that is Electrochemistry. Yeah? The chapter is Electrochemistry. This is the first live session of the Phoenix Pro batch, wherein we shall be starting the chapter Electrochemistry. And this is going to be its first session. Okay? And all the YouTube students who are not the part of this Phoenix Pro batch, for you guys, we are starting your batch tomorrow. Okay, your batch will be started tomorrow. I've given you all the details about that in the yesterday's session. Okay? So all ready for it? All ready for the session? No, I'm not going to take this session pretty long. It is just going to be for like 1 hour. It's going to be there for 1 hour. Right? Maximum I'll take 1 hour. Perfect. So should we start? All ready? Just let me make certain things perfect here. Just a second. I want your chats to be enlarged so that I could see what you are writing in the chats. Just a second. Just a second. Okay. Perfect. So my dear students, before starting this particular session, there will be, I'm pretty much sure, a lot of students among you who would still want to be the part of the batch. Yes, you're most welcome. This is the first session of this particular Phoenix Pro batch. You guys can join in. Link is there in the description. And in this batch also, we are completing the whole syllabus in 6 months. DPPs, study material, test series, one-on-one mentorships, every single thing is provided here in this particular Phoenix Pro batch. Okay? So without wasting a lot of your time, let's get going. Let's get started with the chapter Electrochemistry. Just let me know in the chats whether you guys have studied this particular chapter before or not. I just want to know it. Anyways, I'm going to start from the basics, from the scratch only. But still, I would want to know whether you guys have studied this chapter before or not. I just want to know it. Just say yes or no in the chats. Just say yes or no in the chats. And again, I'm repeating all my YouTube students, right? For you guys, tomorrow, we are starting properly, right? As I have given the details in the yesterday's session. I just want to know, have you guys done this particular chapter before? Just say yes or no. Just say yes or no. All right, all right. Just say yes or no in the chats. So I believe a lot of students have already covered this chapter before also. That's great. And there are a lot of students who have not studied this chapter before. No need to worry. I'll be starting exactly from the basics, from the scratch, I'll be starting as if you have never studied this chapter before. Okay, perfect. So let me turn on the dark mode. Yeah, I believe the dark mode is on. Okay, now I would want you guys to completely focus on the screen. I would want you guys to completely focus on the screen. Whatever things I'll be mentioning on the screen, take a note of every single thing. And at the end of the session, I'll be sharing the session PDF with you on my Telegram channel. The ones who are not the part of the Telegram channel yet, do join the Telegram group, which is Wassim Bhat Chemistry Official, right? You guys can join in, and later on, you guys will be getting the notes of this particular session, which I'm starting now. Perfect, guys. So I'm going to start this particular chapter with certain basic things. So let me mark the heading as Basics Required. Basics required for electrochemistry. Basics required for electrochemistry. So let's first of all try to cover up certain basic things so that there won't be any issue in understanding this particular chapter, right? So I'm going to cover certain basic things which are really very important. Okay, a lot of students might be knowing those basics already. A lot of students might not know. So this is for everyone. So my dear students, the first and the basic terminology with which we shall be starting it. What is that? That is the term oxidation. That is the term oxidation. Now the point is, how do we exactly define the term oxidation? How do we define the term oxidation? My dear students, there are many ways by means of which you can define the term oxidation. But I do not need many ways here. I just want you guys to remember 2 lines. Just 2 lines I want you guys to remember, that's all. My dear students, oxidation, it involves loss of electrons. Oxidation involves the loss of electrons. Whenever you see an element undergoing increase in the oxidation state, whenever you see an element undergoing increase in its oxidation state, understand that element will be undergoing what? That element will be undergoing oxidation. So, increase in the oxidation state of an element is termed as oxidation, which involves what? Which involves loss of electrons. For example, let's say I have got an element A. Okay? Let's say this A is getting converted into A positive, and over here, you're getting 1 electron. This is one general reaction which I've mentioned over here. Let's say this particular A, it's undergoing loss of electron, and after losing 1 electron, this A is getting converted into A positive. So the first thing, my dear students, which I want you guys to understand, just check it out. In this particular reaction, what is happening? Is the loss of electrons happening or gain of electrons happening? You can see A is losing electron and getting converted into A positive. So this particular reaction over here, it involves the loss of electrons. And any such reaction that involves the loss of electrons, you call that particular reaction as the oxidation reaction. So this is my oxidation reaction. Point number 1. Point number 2. My dear students, is there any charge present on this A? No, there is no charge present on this A. Is there any charge present on this A over here? Yes, the charge is +1. The charge is +1. If you think logically, I would say this 0, this is the initial oxidation state of A. This +1, it is the final oxidation state of A. So what is happening exactly? What is happening? The oxidation state of A is changing from 0 to +1. The oxidation state of A is changing from 0 to +1. So what is happening? I would say the oxidation state of A is increasing, 0 to +1. Increase in the oxidation state. And as I told you, increase in the oxidation state is something which you call as oxidation. So I can directly say this A over here, it is undergoing oxidation. This A over here, it is undergoing oxidation. If it is undergoing oxidation, that means it will be losing electrons for sure. Yeah, number 1. Number two, my dear students, I'm pretty much sure you all would have come across the term reduction. How do we define the term reduction? There are many ways by means of which you can define the term reduction. But I do not want you guys to remember all of that. Just two things. Number one, reduction involves gain of electrons. Number one. Number two, decrease in the oxidation state of an element is termed as reduction. Decrease in the oxidation state of an element is termed as reduction. For example, my dear students, for example, I have got an atom A. Let's say it is gaining one electron, it is accepting one electron, and it is getting converted into A negative. Right? I've taken an atom A, it is gaining one electron, getting converted into A negative. Now, what is happening in this particular reaction? If you look carefully, what is happening? Is this reaction involving loss of electrons or gain of electrons? This particular reaction, it is involving gain of electrons. A is gaining one electron, getting converted to A negative. And any such reaction that involves gain of electrons, what do you call that reaction as? You call that particular reaction as the reduction reaction. So this is the example of your reduction reaction. Now, what is important here, people? What is important? Understand. If I ask you, is there any charge over here on this A? You'll say no. Is there any charge over here on this A? Absolutely yes. How much exactly? -1. What is happening to the oxidation state of A? The oxidation state of A is changing from 0 to -1. 0 to -1. 0 to -1. What does it mean? What does it mean? Decrease in the oxidation state. 0 to -1. Decrease in the oxidation state. And my dear students, as I told you already, decrease in the oxidation state is something which you call as a reduction, right? And a reduction involves gain of electrons. So I would say A over here, it is undergoing reduction. It is involving gain of electrons. Okay? I believe these two basic terminologies are absolutely clear to you. Just these two basic terminologies I want you guys to remember. Increase in the oxidation state is what you call as oxidation, and during oxidation, loss of electrons happen. Right? Similarly, decrease in the oxidation state is something which you call as reduction, and in reduction, during reduction, what happens? Gain of electrons takes place. Perfect? Yes. Moving ahead. Moving ahead, my dear people. This is complete basics which I'm telling you right now. Now, you must have heard about something called as oxidizing agent. Guys, these are some terminologies which we are going to frequently use in the chapter Electrochemistry. That's why I'm making them clear right here. Oxidizing agent. Well, oxidizing agent, there is one more name for oxidizing agent. What is that? That is oxidant. Either you call it as the oxidizing agent or you can call it as the oxidant. Now, what is an oxidant? What is an oxidizing agent? Oxidizing agent is basically a substance. It is basically a substance that oxidizes others. That oxidizes others. But itself undergoes reduction. But itself undergoes reduction. So any species, any substance that is going to oxidize others, and itself will be undergoing reduction, you'll be calling that as the oxidizing agent. In short, oxidizing agent oxidizes others, itself undergoes reduction. Oxidizing agent oxidizes others, itself undergoes reduction. Similarly, if you ask me, what is a reducing agent? What is a reducing agent? Whether you call it as the reducing agent or you can call it as the reductant. You can call it as the reductant. So what is a reducing agent? What is a reductant? Let's get to know about that. My dear students, reducing agent. Reducing agent is that particular substance, the substance that reduces others. But itself undergoes oxidation. So reducing agent is going to reduce others, but itself will undergo oxidation. Oxidizing agent is going to oxidize others and itself will undergo reduction. Again, I'm repeating. Oxidizing agent oxidizes others, itself undergoes reduction. Reducing agent reduces others, itself undergoes oxidation. Now the point is, how do we identify the oxidizing and reducing agent in a chemical reaction? Try to understand, people. Try to understand very carefully, because this is something which I'll be using everywhere in the chapter Electrochemistry. My dear students, for example, I'm writing a reaction, a general reaction I'm writing. General reaction. I'm writing something like this. Zinc plus copper dye positive. Let's say it gives zinc dye positive plus copper. This is the reaction which I've mentioned over here. Now, my dear students, if I ask you, do you see any charge on zinc here? Absolutely not. Do you see any charge on copper here? Yes. How much exactly? +2. Do you see any charge on zinc here? Yes. How much exactly? +2. Do you see any charge on copper here? No. 0. Now try to understand. Try to understand, people. Try to understand one simple thing, which I'm trying to show you over here. If I ask you, what is the initial oxidation state of zinc? You will say initial oxidation state of a zinc is 0. What is the final oxidation state of zinc? It is +2. So oxidation state of zinc is changing from 0 to +2. What is meant by 0 to +2? What does that mean? What is happening? Is the oxidation state of zinc increasing or decreasing? 0 to +2. Oxidation state of zinc is increasing, right? And you must be knowing, increase in the oxidation state is something which you call as oxidation. So I would say the zinc over here is undergoing oxidation. And the one which undergoes oxidation, what it does? It loses electrons. So basically, in this particular reaction, zinc will be losing electrons. Yeah? Zinc will be losing electrons. How many electrons? That is a different debate, which we'll get to know after some time. Let's not talk about that yet. So first of all, zinc is undergoing oxidation. It is losing electrons. And the one that undergoes oxidation, what do I call that as? I call that as a reducing agent. So the zinc over here is behaving like the reducing agent. Right? Now similarly, if you look carefully, what is happening to the oxidation state of copper? +2 to 0. +2 to 0. What is happening? Decrease in the oxidation state. Decrease in the oxidation state. And my dear students, decrease in the oxidation state is something which you call as a reduction. In reduction, what happens? Gain of electrons takes place. So I would say this copper dye positive will be gaining electrons. This copper dye positive is undergoing reduction. It will be gaining electrons. And the one that undergoes reduction, that is something which you call as oxidizing agent. So this is how you identify in a reaction which substance is your oxidizing agent and which substance is your reducing agent. Right? Someone is saying, sir, ye pata hai, question karao. So I would want you to not watch this session, come in the second, third part, right? Because this session is all about the basics. I'm not going to do any sort of questions here. I'm just making the basics clear. Okay? Perfect. You can check some of my one shot of electrochemistry. You'll get to know some good questions, which I'm pretty much sure you won't be able to solve on your own. Okay. Perfect. Look at the next reaction. Look at the next reaction. I'm giving you certain examples by means of which you can identify which substance is your oxidizing agent, which substance is your reducing agent. Try to understand, people. For example, I'm writing a reaction like this. H2 plus, for example, 2 times Ag positive. It gives 2 times H positive plus, let's say, 2 times Ag. This is one general reaction again. This is a general reaction again, which I've written over here. Now, my dear students, I need to identify which species is acting as the oxidizing agent and which species is acting as the reducing agent. Let's get to know about this. First of all, if I ask you, is there any charge on this hydrogen? You'll say no. If I ask you, is there any charge on this silver? You'll say yes. How much? +1. Any charge on this hydrogen? Yes, +1. Charge on silver? No, 0. What is happening? 0 to +1. Increase in the oxidation state. Increase in the oxidation state is something which you call as oxidation. So this H2 is undergoing oxidation. The one that undergoes oxidation, that's something which I'll be calling as the reducing agent. Yeah? Similarly, what is happening to the oxidation state of silver here? +1 to 0. plus 1 to 0, decrease in the oxidation state. Decrease in the oxidation state is something which I call as reduction. So this Ag positive is undergoing reduction, and the one that undergoes reduction, that is my oxidizing agent. So this is how you're going to identify from now onwards which substance is your oxidizing agent and which substance is your reducing agent. Yeah? Perfect. Is it clear, people? Is it clear? Now you guys are going to let me know. For example, I'm writing a reaction like this. MnO4 negative plus Fe di positive. Let's say it gives Mn di positive plus Fe tri positive. So in this particular reaction, can you let me know which one is your oxidizing agent and which one is your reducing agent? You can do that in the similar manner. You can do that in the similar manner. How exactly? First of all, try to calculate the oxidation state of this manganese. How exactly? Let the oxidation state of manganese be X. Normally, oxygen shows -2. How many oxygen atoms? 4. Net charge is -1. So the value of X comes out to be +7. So +7 is the oxidation state of this manganese over here. What is the oxidation state of this iron? It's +2. This manganese, +2. This iron, +3. Right? This is something which I've done so far. This is something which I've done so far. Now, my dear students, just try to understand one thing. If I ask you what is happening to the oxidation state of manganese, +7 to +2, decrease in the oxidation state. Decrease in the oxidation state is something which you call as a reduction. But my dear students, be careful. I will say this entire species over here, it is undergoing reduction. I will say this entire species is undergoing reduction. The one that undergoes reduction, that is definitely going to behave like the oxidizing agent, right? Similarly, if you talk about this Fe di positive, +2 to +3, increase in the oxidation state. Increase in the oxidation state is termed as oxidation. So the one that undergoes oxidation, that has to be my reducing agent. So this is how you're going to identify your oxidizing agent and reducing agent. Yeah, as simple as that. Okay. Now, people, one more example I'm giving you. Let's say you've got something like this. Cr2O7 dinegative plus C2O4 dinegative, right? Let's say it gives your chromium tri-positive, and with this, for example, you're getting carbon dioxide. This is one general reaction which I wrote over here. Now, again, I need to identify which one is my oxidizing agent, which one is my reducing agent. Why am I focusing on this, people? Why am I focusing on all this stuff? The point is because this is something which I'll be using everywhere. Okay. Now, first thing, what is the oxidation state of chromium here? You can calculate it. 2x minus 14 is equal to -2. So x value will come out to be +6. What is the oxidation state of carbon here? 2x minus 8 is equal to -2. So x value will be +3. What is the oxidation state of chromium here? It's +3. What is the oxidation state of carbon here? It's going to be +4. X minus 4 is equal to 0. Right? Now think carefully. Think carefully. +6 to +3. What is happening? Increase or decrease? +6 to +3. Decrease in the oxidation state. Decrease in the oxidation state is something which you call as a reduction. So this species is undergoing reduction. The one that undergoes reduction is my oxidizing agent. Okay. +3 to +4. Increase in the oxidation state. Increase in the oxidation state is something which I call as oxidation. So I would say the species is undergoing oxidation here. And the one that undergoes oxidation is going to be my reducing agent. Now tell me whether in any sort of reaction you can identify your oxidizing and reducing agent. If yes, let me know yes in the chats. Then I'll move ahead. Quickly in the chats. Quickly, people, let me know in the chats. Yeah? All clear? All clear, all clear, all clear? Say it in the chats quickly. Yes or no? Yes or no? Perfect, guys. Perfect. Let's move ahead then. Let's get into the first topic of electrochemistry. First topic of electrochemistry, right? Let's start now. What is that? That is your electrochemical cell. Electrochemical cell. So first of all, what is an electrochemical cell? How do you define the electrochemical cell? It's simple, guys. It's simple. Electrochemical cell is basically the device. It is a device. It is the cell that converts either chemical energy into the electrical energy, or vice versa. So any cell, any device that converts either chemical energy into electrical energy or electrical energy into chemical energy. What do I call that cell as? I'll be calling that particular cell as the electrochemical cell. So it's the device that converts either chemical into electrical or electrical into chemical. I'll be calling that as the electrochemical cell. Okay? Now, my dear students, we have to discuss basically two types of electrochemical cells. We have to discuss two types of electrochemical cells. One is something which you call as galvanic cell. Galvanic cell, or you can call it as the voltaic cell. The first type is your galvanic or voltaic, and the second one is your electrolytic cell. Electrolytic cell. And these two cells in this particular chapter we are going to discuss in very much detail. Very much detail. But right now I'll just give you the elementary idea of these two cells. Let me give you the elementary idea of these two cells. My dear students, if I talk about the galvanic cell, galvanic cell, what is it? It is a device. It is a device that converts chemical energy into the electrical energy. It converts chemical energy into the electrical energy. Point number one. What you will observe in the galvanic cell, you'll observe one thing. I'm going to discuss this galvanic cell in detail in some time, right? I'm just writing certain things first, okay? In case of galvanic cell, what you'll observe some spontaneous cell reactions taking place. You'll observe some spontaneous cell reactions taking place. You'll observe some spontaneous cell reactions taking place, by means of which current is going to get generated. And for any process to be spontaneous, delta G has to be negative. So, if in case of galvanic cell, spontaneous cell reactions are taking place, I'll say delta G for the reactions, it is supposed to be negative. I'll explain all these points one by one, right? Now, in case of galvanic cell, what you'll observe, in case of galvanic cell, we use two electrodes. One is called as anode, one is called as cathode. In galvanic cell, how many electrodes we are going to use? We are going to use two electrodes. Your anode, one is called as anode, one is called as cathode. My dear students, what you will observe in galvanic cell, you'll observe the rod of anode. The rod of anode carries a negative charge. And the rod of cathode, it carries a positive charge. From where this negative positive comes, that's again something which we'll be discussing in some time. But remember all these things first. In case of a galvanic cell, I'll be using two electrodes. One is your anode, one is your cathode. Remember, at anode always oxidation takes place. At anode always oxidation takes place. And during oxidation, what happens? Oxidation involves loss of electrons. And at cathode, do remember, always what is going to happen? At cathode, reduction takes place, and reduction involves gain of electrons. These are few points which I would want you guys to remember directly from now onwards. If I talk about the galvanic cell, what exactly it's going to do? It is going to convert your chemical energy into electrical energy. What you'll observe in the galvanic cell? Spontaneous cell reactions are going to happen, right? Spontaneous cell reactions are going to happen, due to which current will get generated. Okay? You'll observe that in some time. Perfect. Now, for any reaction to be spontaneous, its delta G has to be negative. In case of galvanic cell, we'll be using two electrodes. One is something I'll be calling as cathode, one is something I'll be calling as anode. At cathode, oxidation takes place, loss of electrons. At cathode, reduction takes place, gain of electrons. The rod of anode carries the negative charge here. The rod of cathode carries the positive charge here. This is the general overview of the galvanic cell. Now, if you talk about the electrolytic cell, what electrolytic cell does? Just reverse of it. Electrical energy into what? Into the chemical energy. Okay? Right? This point number one. Electrical energy into the chemical energy. Number one. Number two. Cell reactions are made. Over here, first of all, cell reactions are carried out, I'll say. Cell reactions are carried out with the help of external agent. What is that external agent? That's again something which we'll be discussing in detail. Over here, cell reactions are not going to happen spontaneously. They are not going to happen on its own. Cell reactions are made spontaneous with the help of external agent. So technically, if you ask me, whether cell reactions are going to happen on its own, no. Cell reactions are carried out with the help of external agent, right? Okay, so if I ask you what will be delta G for the reactions then, that will be positive. Okay, now again here in this particular case, you are going to use two electrodes. One I'll be calling as anode, another one I'll be calling as cathode. But my dear students, do remember the rod of the anode in electrolytic cell that carries the positive charge, the rod of the cathode carries the negative charge here. Just the reverse of this. And you should know at anode what happens? Oxidation. At cathode what happens? A reduction. Oxidation involves loss of electrons. Reduction involves gain of electrons. Perfect. This is the quick overview of the two things. One is your galvanic cell, one is your electrolytic cell. Now, my dear students, our main topic, our actual topic is going to be the galvanic cell. It is going to be the galvanic cell. So till now, whatever I was teaching you, this was all the basics, and I believe it is strongly clear to everyone. Okay? Perfect. All clear till here? Say it in the chats. Say it in the chats, people, if every single thing is clear till here. Say it in the chats whether yes or no, if all the things are clear till here. Quickly, people. Quick. So now we are going to start our first topic of the chapter, that is your galvanic cell, right? My dear students, if I talk about the galvanic cell, I have given you the overview of the galvanic cell. I have told you what this galvanic cell does. Galvanic cell converts chemical energy into electrical energy. Now the point is how exactly it does so. How it converts chemical energy into electrical energy, right? But before talking about all that stuff, let me tell you the most typical example of the galvanic cell is your Daniel cell. So basically, we are going to look at the Daniel cell, how exactly it works, how exactly it converts chemical energy into what? Into the electrical energy. This is something which we are going to see now. But before saying it's working, before seeing its construction, etc., let me tell you, in case of Daniel cell, which is the typical example of the galvanic cell, which is going to convert chemical energy into electrical energy, let me tell you, I'll be using two electrodes. One is going to be your zinc electrode, and one is going to be your copper electrode. How many electrodes I'll be using? I'll be using two electrodes to make the Daniel cell. One is going to be your zinc electrode, one is going to be your copper electrode. My dear students, if you compare zinc with copper, if you compare these two, zinc with copper, zinc is considered to be more electropositive. And comparatively copper is considered to be less electropositive. right? The one that is more electropositive, that will be having more tendency to lose electrons. And loss of electrons, that takes place at anode. So do remember, I'll be no doubt using two electrodes, zinc and copper. Out of these two electrodes, the zinc electrode is going to behave like the anode and copper electrode is going to behave like the cathode. Right? And one thing is clear, at anode what happens? At anode oxidation takes place and at cathode reduction takes place. Oxidation involves the loss of electrons and reduction involves the gain of electrons. These are the two basic points which you need to remember. Now people, let's try to understand how this cell exactly works, how it converts chemical energy into electrical energy. That is our main point of discussion. So the first thing, how many electrodes we'll be using? Two electrodes. One is your zinc, one is your copper, right? Zinc, anode, copper, cathode. At anode, oxidation, loss of electrons. At cathode, reduction, gain of electrons, right? Now let's try to understand this galvanic cell in detail. Let's see how exactly it works. So, as I told you, the most common example of the galvanic cell is your Daniell cell. So let me mark the heading here as Daniell cell. So my dear students, as I told you, in case of your Daniell cell, how many electrodes I'll be using? I'll be using two electrodes. One is your zinc, right? So let me make a zinc electrode over here. Now, how exactly you guys are going to make the zinc electrode? How exactly? Understand how this electrode is made. First of all, I'll be taking a container. This is one small container that I took, right? This is one container that I took. My dear students, in this particular container, I'm going to keep an electrolytic solution. Containing what? Containing zinc sulfate. Over here in this particular container, I have kept an electrolytic solution containing zinc sulfate. The zinc sulfate which is there in the container, definitely the zinc sulfate would have undergone dissociation as zinc di positive plus SO4 di negative, right? So in this particular container, what all ions do I have? In this container, I have got zinc di positives as well as SO4 di negative. And I would say right now in the container, we have got equal number of zinc di positives and SO4 di negatives. We have got equal number of these two. And my dear students, if you have got equal number of cation and anions, so I would say this particular solution right now is going to be electrically neutral because there are equal number of cations and anions in this container. So this particular solution, it is supposed to be electrically neutral. Okay. Now, my dear students, in this particular container, what exactly am I going to introduce? I am going to introduce a zinc rod. This is your zinc rod which I have introduced over here. Can I say I have introduced zinc rod in a solution which contains its own ions? I've introduced zinc rod into a solution that contains its own ions. Zinc rod is dipped in a solution that contains zinc dipositive. So I'll be calling this complete setup as the electrode. Whenever a rod is placed in a solution containing its own ions, you'll be calling the complete setup as the electrode. So this is my zinc electrode over here. I've inserted zinc rod into a solution containing zinc dipositives. Okay, so this is my zinc electrode over here. Similarly, I'll be taking one more electrode over here. Which one that's going to be? That's going to be copper electrode. How exactly you guys are going to make the copper electrode? Again, you are going to take a container. In this particular container, what exactly you guys are going to keep? You guys are going to keep copper sulfate in this particular container. And copper sulfate in this container, I would say it would have undergone dissociation, right? It would have got converted into copper di positives and SO4 di negatives. So in this particular solution, what kind of ions do we have? We have got copper di positives as well as SO4 di negatives, right? And let me tell you, we have got equal number of copper di positives and SO4 di negatives right now in the container. If we have got equal number of copper di positives and SO4 di negatives in this container, I would say this particular solution right now, it is electrically neutral. Now, what exactly I'm going to do? I'm going to introduce a copper rod in this particular solution. This is the copper rod which I've introduced. Copper rod is introduced in a solution that contains its own ions. Copper rod is introduced in a solution that contains its own ions. So this setup again I'll be calling as electrode. And which electrode? You'll be calling this as the copper electrode. So how many electrodes have I taken over here? I've taken 2 electrodes. One is your zinc electrode, one is your copper electrode. Now, my dear students, since the 2 electrodes which I've taken, I'm going to connect these electrodes. Let me connect these electrodes. Let me connect these electrodes with the help of a voltmeter, right? And this voltmeter is going to show deflection after some time. So over here, I've connected these electrodes with the help of voltmeter, which is going to measure the deflection. Now, if I ask you, is the circuit right now complete? Is the circuit right now complete? The circuit is not complete right now. The circuit is externally complete. Internally, it's not complete. It is not a closed loop yet. It is not a closed loop yet. Now, in order to complete the circuit right now, what exactly I'll be doing? I'll be taking an inverted U-type tube. This is the inverted U-type tube which I've taken. This is the inverted U-type tube which I've taken. And my dear students, this inverted U-type tube, what exactly I'm going to keep in this inverted U-type tube? I am going to keep an inert electrolyte. I am going to keep an inert electrolyte in this inverted U-type tube. Inert electrolyte, for example, you have got K2SO4. For example, you have got NH4Cl, etc., etc. These are something which I call as inert electrolytes. Now, my dear students, this inert electrolyte, I'm going to mix the inert electrolyte with gelatin or agar-agar. So, the inverted U-type tube which I've taken, in the inverted U-type tube, what exactly am I going to keep? I'm going to keep an inert electrolyte, which I'm going to mix with gelatin or agar-agar. And when the inert electrolyte is mixed with gelatin or agar-agar, what do we get? We get a jelly-like paste. We get a jelly-like paste. And that jelly-like paste I am going to introduce here in this inverted U-type tube. So this inverted U-type tube contains a jelly-like paste. How exactly you got that jelly-like paste? You took the inert electrolyte and you mix that inert electrolyte with gelatin or agar-agar, you got the jelly-like paste, and that jelly-like paste you inserted in this inverted U-type tube. And my dear students, the ends over here of this particular inverted U-type tube, you are going to seal these ends with the cotton balls. You are going to seal these ends with the cotton balls, right? Seal these ends with the cotton balls, okay? Now, my dear students, if I ask you in this inverted U-type tube, what kind of ions do we have? For example, I've kept this inert electrolyte over here in this inverted U-type tube. So I would say in this inverted U-type tube, what do we have? We'll be having the K positive ions, and we'll be having SO4 dinegative ions in this inverted U-type tube. Yes, we'll be having 2 types of ions here. SO4 dinegatives, K positives in this inverted U-type tube. And this inverted U-type tube that contains a jelly-like paste, what do I call this inverted U-type tube as? I call this inverted U-type tube as the salt bridge. I call this as the salt bridge. So what is the salt bridge? It is the inverted U-type tube that contains the inert electrolyte which is mixed with gelatin or agar-agar, with the help of which you get a jelly-like paste, and that jelly-like paste is inserted here in this inverted U-type tube. Yeah? Right, people? Now, if I ask you, is the circuit complete now? Externally it's complete, internally it's complete, right? Okay? As I told you, in case of Daniel's cell, what happens at anode? What happens at anode? What happens at anode? At anode, at this electrode, oxidation is going to take place. At this cathode, reduction is going to take place. This is something which we already know. At anode, oxidation is going to take place. At cathode, reduction is going to take place. Now, my dear students, the zinc electrode, that is my anode. The zinc electrode is my what? It is my anode. Okay. And at anode, what happens? Oxidation takes place. Oxidation involves loss of electrons. This copper electrode, this is my cathode. And at cathode, what happens? Reduction takes place. Reduction involves gain of electrons. Reduction involves gain of electrons. So my dear students, what is going to happen here? Oxidation is going to take place. Oxidation means loss of electrons. What exactly you mean by loss of electrons? See, if I talk about this rod, this zinc rod over here, can I say this zinc rod is made up of zinc atoms? Yes, it's made up of zinc atoms. Now, the zinc atoms of this rod is made up of. The zinc atoms of this rod is made up of. Those zinc atoms, they are going to undergo oxidation. And when a zinc atom undergoes oxidation, let's say this is the zinc atom of which a rod is made up of. When it undergoes oxidation, that means the zinc atom is going to lose electrons. And when it loses two electrons, it is going to get converted into zinc dipositive. So basically this rod, it is made up of zinc atoms, right? Those zinc atoms are going to undergo oxidation. They are going to lose electrons. The zinc atom will be losing two electrons, get converted into zinc dipositive, right? Now people, since this rod is made up of zinc atoms and those zinc atoms are undergoing oxidation, they are losing electrons and they are getting converted into zinc dipositives. I would say those zinc dipositives, they are going to enter into the solution. Understand what exactly I'm saying? They are going to enter into the solution. The solution initially was electrically neutral. Now, an extra zinc dipositive is going to enter into the solution, which makes the solution positively charged. The solution carries now the positive charge. The two electrons which were given by zinc atom, those two electrons are accumulated on the rod. Okay? Similarly, when one more zinc atom undergoes oxidation, again one more zinc dipositive will enter into the solution. Again, two more electrons will be accumulated on the rod. So on the rod, electrons will keep on accumulating with time. And if electrons are accumulating on the rod, which kind of charge the rod is going to have? The rod is going to have the negative charge. This is something which I told you already. The rod of the anode, the rod of the zinc, in case of the Daniel cell, it will carry which charge? The negative charge. Yeah? Now, my dear students, try to understand. Try to understand very carefully. This particular electrode is your cathode. And at cathode, what happens? Reduction. Reduction means gain of electrons. I'll show you at the end how do you enroll into the batch, okay? Just wait for it. Okay, this particular electrode is your cathode. At cathode, what happens? Reduction takes place. Now, my dear students, try to understand very carefully what exactly I'm going to say. In this particular chamber, how many types of ions do we have? Copper dye positive, SO4 dye negative, right? These are the two types of ions which are there in the container, right? The container contains equal number of Cu dye positives, SO4 dye negatives, due to which the solution is electrically neutral. Now, my dear students, if I ask you one thing, the copper dye positives which are there in the solution, I would say those copper dye positives are going to collide with this rod. The copper dye positives, they are going to collide with this rod. And the copper dye positives which were there in the solution, they'll be colliding with the rod. They'll be taking two electrons from the rod. And when copper dye positive from the solution is going to collide with the rod, taking two electrons from the rod, it gets converted into copper solid. And that copper solid will be getting deposited here on the rod. That copper solid will be getting deposited over here on the rod. Now, my dear students, think logically. If copper dye positive in this solution, if it is colliding with the rod, taking two electrons from the rod, can I say electrons are being snatched from the rod, due to which this rod is going to carry the positive charge, right? So the cathodic rod, in case of Daniel cell, is going to carry positive charge. Now, my dear students, electrons are accumulated here already. The path is already created. Can I say what exactly you guys are going to observe? You'll observe the movement of electrons from anode to cathode. You'll observe a movement of electrons from anode to cathode. Right? Electrons are accumulated on this rod. The path is already created. The electrons are going to move from anode to cathode. Now, people, if I ask you, Is it just going to be the movement of electrons? No. No. It is going to be the directional movement of electrons. Electrons are going to move in a particular direction from anode to cathode. From anode to cathode. This is the first question that can be asked. This is the first question that can be asked. What is it? What is the direction of electrons in case of Daniel's cell? The direction of electrons is from anode to cathode. Is it just the direction of electrons? No. This is the direction of electrons in a particular direction. And whenever charge moves in a particular direction, whenever a charge moves in a particular direction, current gets generated. So this voltmeter over here is going to show the deflection now. It is going to show the deflection now. Okay? Current gets generated. And what is the direction of current? The direction of current is always opposite to the direction of electrons. The direction of current is always opposite from the direction of electrons. So the direction of current will be from cathode to anode. So if you look carefully, what happened? Can I say some of the reactions happened at cathode, at anode, due to which current got generated? What I told you in the beginning, what a galvanic cell does, it converts chemical energy into electrical energy. So did you see? Some reactions happened over here. Okay? Due to which current got generated. So chemical energy exactly got converted into what? Electrical energy. That's the work which galvanic cell has to do. It has to convert the chemical energy into the electrical energy. And that's what it did. Yes, that's what it did. Now, people, you must be thinking, in case of Daniel's cell, there is one reaction happening at anode, one reaction happening at cathode. Will there be any net reaction? Will there be any final reaction, net reaction happening in the Daniel cell? Yes, there will be the net reaction. How exactly? How exactly? Yes, I mean the emitter here. Yes, I mean the emitter here. Okay. So how exactly you guys are going to write the net reaction? My dear students, try to understand. See, first of all, you wrote the reaction at anode. Then you wrote the reaction at cathode. Now, after this, you are going to balance the electrons in both the reactions. And in both the reactions, if you think carefully, if you see carefully, in both the reactions, electrons are already balanced. Electrons are already balanced in both the reactions. If electrons are balanced, you can directly add these two reactions. And when you add these two reactions, this two electron got cancelled, and I'll be left with a net reaction. The net reaction will be like this. Zinc solid plus copper dye positive aqueous. What does it give me? It's going to give me zinc dye positive aqueous. With this, you are going to get the copper solid. This is my net reaction, people. This is the net reaction that is taking place where? In case of the... This is the net reaction that's taking place in case of the Daniel cell. How many electrons got cancelled? 2 electrons. What does that mean? What is its significance? It means, I'm writing it over here. I'm writing it over here. N value over here is 2. What does that mean? That means N represents the number of moles of electrons. The number of moles of electrons exchanged. The number of moles of electrons exchanged from anode to cathode. N represents the number of moles of electrons exchanged. And if you could see over here, electrons are exchanged over here from anode to cathode. So number of moles of electrons exchanged in the net reaction, that's equal to 2. So N value here is 2. 2 moles of electrons are being exchanged from anode to cathode here, right? Due to which current is getting reduced. Okay. Now, my dear students, one more thing which I would want to share with you. One more thing which I would want to share with you. What is that exactly? Try to understand. Try to understand. I told you this zinc rod is made up of zinc atoms. Those zinc atoms are undergoing oxidation. And those zinc atoms are getting converted into zinc dye positive. That zinc dye positive enters into the solution. Can I say thickness of this rod will keep on decreasing with time? Because the rod was made up of zinc atoms. Those zinc atoms are undergoing oxidation. They are getting converted into zinc dye positives. Those zinc dye positives are entering into the solution. Due to which the anodic rod, the zinc rod, its thickness will decrease with time. So I would talk about one more conclusion here. Zinc rod, its thickness decreases with time. Its thickness decreases with time. Its thickness decreases with time. Now, if I ask you what is going to happen to the cathodic rod? If I ask you what is going to happen to the cathodic rod? People at cathode, did you observe one thing? The copper dye positives in the solution, They gained 2 electrons. They collided with the rod, took 2 electrons from the rod, got converted into copper solid. That copper solid was deposited over here, due to which the thickness of this particular copper rod, it increased with time. Yeah? Okay? So I would say the thickness of the copper rod. The thickness of the copper rod. Thickness of the copper rod. It increases with time. Thickness of the copper rod increases with time. So what is the conclusion? What is the conclusion? What happened here? What happened here? My dear students, certain chemical reactions happen due to which current got generated. That's what a galvanic cell does. Okay. Now, people, you must be thinking, what is the working of this salt bridge? I mean, what the salt bridge does? You must be thinking, right? You must be thinking what the salt bridge exactly does. My dear students, salt bridge has got a lot of functions. There are certain functions which salt bridge has, and all those functions of the salt bridge I'll be sharing with you in the second session of electrochemistry. Okay? So this was the first live session of the Phoenix Pro batch. This was not the YouTube class, right? This was the first live session of the Phoenix Pro batch, which is getting started today. Perfect. And all the students who would want to be the part of Phoenix Pro batch, which has got started today, and today we are taking the first live session. Okay, my dear students, there's a link in the description box of the video. Just click on that link. Let me show it to you. This video you guys are watching right now, there's a link in the description box of the video. Click on this link. Once you click on this link, automatically you'll be directed to this particular page. Over here you can select two options. Either you can go for plus or you can go for iconic. In plus, you get study material in the form of PDF. In iconic, you get study material in the form of booklets, and those booklets are delivered to your houses, etc., right? So you can just select any one of the two, click on 12 months, click on proceed to pay. Once you click on proceed to pay, right now this particular batch, the Phoenix Pro batch, you are just getting at the rate of 4,999. And what all benefits you guys have in this Phoenix Pro batch? Let me tell you, your entire syllabus will be complete in 6 months, followed by revision for 2 months. Your Unacademy NEET English team is going to train you completely in all the subjects, right? Apart from that, whatever portions we complete in 14 days, on the 15th day, right, you'll be having a test. Okay, we conduct your tests. Perfect. Apart from that, if you be the part of the Phoenix Pro batch, you'll be having the access to the special rankers group as well. Okay, special rankers group is the one from which Unacademy every year gets single digit, double digit ranks. So you guys will be the part of the special rankers group. You'll be provided with the DPPs of every chapter. You'll be provided with the study material. Perfect. Whether you want the booklets, go for iconic subscription. Whether you want the PDF, go for plus subscription. So that's all included, right? Once after the syllabus completion, everyone looks for the All India Test Series. All India Test Series is included here, right? It's included. You are getting the All India Test Series as well. And apart from that, my dear students, syllabus completion, study material, getting trained by the Unacademy NEET English team. Apart from that, if you be the part of this particular batch, you will be having the access to all the batches of Unacademy absolutely free of cost. Okay? Right? Okay, if you enroll into this particular batch, you'll be having the access to all the batches of Unacademy absolutely free of cost. Whether you want to study chemistry from me, whether you want to study physics from some other teacher of Unacademy, another batch, you can do that. Bio from some other batch, you can do that. Or chemistry from some other batch, you can do that. That option is kept open for all of you. Okay, so be the part of the batch. Get enrolled right now if you are not, and join the live classes with us from tomorrow on the Unacademy platform. The sessions of Phoenix Pro batch, they're not going to happen on YouTube. They'll happen on Unacademy platform, right? And all my YouTube students, from tomorrow, people, I'm starting your classes regularly on this channel as well. Okay, you also need not to worry. Perfect. Perfect, people. Chalo. With this, I'm going to take a leave. Well, someone is asking about the class timings. Class timings will be different, right? For example, I take my class in the morning at 7 a.m. Yavar sir takes in between, Ambika ma'am takes in between, right? And at the same time, if you by chance are not able to join the live classes, you will be having the access to the recordings as well. You can check the recordings. No issues at all. Perfect. And the classes are going to be in English language. We are the ones who are going to train you. Okay? Perfect. Someone is saying block क्यों किया है? आपने परेशान किया होगा इसलिए block किया होगा. Chalo guys. With this, I'm taking leave. I'll see you in the live sessions. Take care. God bless you all and love you all. Bye-bye.